Hello class, welcome to the JMP video for chapters 7 and 8. To begin, we're going to open up JMP and then go to eCampus and open up the real estate data. So under eCampus, I'm going to select data sets, other data sets, and I will be selecting the real estate data. Now for the first part of this video, we're going to focus on simple linear regression. So we're only going to focus on the real estate data column selling price and size. When we move on to the multilinear regression, we'll focus on the condition. So to begin, we are going to analyze our simple linear regression data by using the analyze fit model command. Analyze, or excuse me, not fit model, fit y by x. Size is our factor. Selling price is our response. I'm going to select OK. As is traditional, we see a scatter plot of our response and predictor information. I'm going to select this red triangle and select the option that says fit line. This tells JMP that we are doing a simple linear regression. And now you can see the output that was given to us in our Chapter 7 Part 1 notes. And we have our selling price, linear fit, our least squares line. We have our R squared, mean response and observations that we covered in our first part of our Chapter 7 video. And we have our ANOVA table. Notice under parameter estimates, we have the estimates that do correspond to our least squares line. And we also have corresponding standard error, t-ratio, and our p-value, which is something that we discussed in the second part of our Chapter 7 video. Now, we may be interested in seeing a correlation matrix to give us our correlation coefficient. Again, this is something we talked about in the first JMP video. So I'm going to minimize this. And in order to get those correlations, we are going to go to Analyze, Multivariate Methods, and select multivariate. And again, for this simple linear regression part, we just care about size and selling price. And we're going to select OK. And we're really going to be concerned with this correlation matrix here. Obviously, the correlation between selling price and size are both going to be 1. What we are interested in is the correlation between our response and our predictor, which is the 0.9379. If you don't remember how we would interpret this value, it indicates that we have a fairly strong positive linear relationship. So this brings us to the end of page 1 in our JMP handout. So let's move on to page 2 and talking about how to calculate confidence intervals for slopes and intercepts. So I'm going to exit out of our multivariate screen. And this is only available in the Analyze Fit Model report. The Analyze Fit Y by X report is pretty much only used for simple linear regression. But we can use the Fit Model report for both simple linear regression and multilinear regression. So if we go to Analyze, Fit Model, size is our effect, selling price is our response. Notice under personality it says standard least squares, just an FYI, nothing you have to do with that, but just know that it is talking about the least squares. And so once again, the same summary output we saw when we did the Fit Y by X report. We have the same summary of fit, same ANOVA table, and the same parameter estimates. So if you want to save yourself a step, you don't necessarily need to do the Fit Y by X. You can go straight to the Fit Model report, and just know that to create your least squares line, you have to use the parameter estimates for your intercept and slope. So going back to our handout, we wanted to talk about calculating our confidence intervals. So in order to do this, we can select our red triangle Under regression reports, we can select show all confidence intervals, and it will automatically then output the 95% confidence interval for our slope and y-intercepts. In the event that we would like to change the confidence level, because the default is going to be 95%, I can exit out. I will go to Analyze, Fit Model. We'll still have the same size and selling price, but where it has the red triangle and says Model Specifications, I can set the alpha level to the desired level. The default is 0.05 or 95%, but again, if we wish to change that, we can do so here. All right, so now at this point, we may be interested in plotting our confidence intervals and prediction intervals. So once again, we can run the fit y by x linear fit. And I can select OK. Now at this point, we will select our fit line as is traditional. And then furthermore, we're going to reselect that red triangle. And at this point, I apologize, I told you to select the wrong red triangle. It is the red triangle attached to the linear fit. I was wondering why I couldn't find the options I was looking for. Helps if I read the handout, isn't it? So on this report, I'm going to want to select confidence interval curves fit and the confidence interval curves individual. Remember, the individual is how JMP talks about the prediction intervals. And so now we have a visual representation. Notice that the prediction interval is wider than the confidence interval. And so we're saying anything that's between these initial two or inner two dotted lines, that is the acceptable range for our confidence interval, and then the outer two dotted red lines are the range for our prediction interval. Now to actually go ahead and physically calculate our prediction and confidence intervals, we are going to have to switch gears and go back to the fit model report. I know this can be a bit confusing, that's why we have the handout. So once again, I'm going to go to Analyze Fit Model. Size is our effect, selling price is our response. Going to run, and we're going to need to use those Save Columns features. So under the red triangle, we'll collect Save Columns, and we're going to be interested in saving a bunch of columns, included the predicted values, standard error of predicted, mean confidence interval, and individual confidence interval. And because I didn't change the alpha value, we are going to keep it at 95%, but again, we could change that to being 99 or 90% as we need. So red triangle, save columns, we want predicted values, standard error of our predicted values, and then our mean and individual confidence intervals. And I know it is kind of a bit eerie that you click on this and then you don't necessarily see the results, but it is happening on the table below. So individual confidence intervals. So I'm going to minimize out of our fit model report and temporarily maximize our JMP screen, and we can see that we have our predicted selling price. So that's our mu hat of y given x, the standard error of our selling price, and then we have our 95% confidence interval, our lower and upper bounds, and then the individual, which is our prediction interval. And if at any point in time you're interested in what would happen, you can always plug in additional values below and see the corresponding results. So for example, if I wanted to say, all right, if I have a if I have a house that is in condition 4, or excuse me, we're not actually concerning ourselves with condition, we're concerning ourselves with size, my bad. Let's say we have a house that is size of, say, 27, and the actual selling price is 80, we can go back through and recalculate to adjust our new values. So if I minimize this out, you can see what I just talked about below with what will happen if you add a new column and try to get some new information. And this will be helpful, particularly when you do your homework. All right, next let's talk about our ANOVA table. So the simple linear regression ANOVA table is the default output in both our fit model report and our fit y by x. At this point, we can start talking about our multilinear regression knowledge. So beginning, let's talk about how we would go ahead and fit that report. So once again, I'm still using that real estate data. And I'm going to take a moment and I'm going to delete these previous columns. We don't really need them at this moment. And I'm going to clear these 2 rows to give us just our original data. Okay, so now we're doing multiple linear regression, so we are going to be concerned with the conditions column. So to begin, how do we analyze in multilinear regression? This time we are going to be pretty much strictly using the fit model report. Again, the fit y by x is really only useful for simple linear regression and other things we've talked about previously. So analyze, fit model, selling price is still our response, and now this time both size and condition are going to go under model effects. So I'm going to add it, run it, and I'll be able to see my summary of fit and overall ANOVA and my parameter estimates that we can use to make our least squares line. Going back to our handout, let's see, summary of fit table, just follow the instructions from slide 149 because summary of fit table is default. Yes, it is. Talking about showing all confidence intervals, again, same process. We can hit the red triangle under regression reports. We can say show all confidence intervals. We can also generate a jump report to create our confidence intervals of interest. Same process as we did before where we are saving columns. So we're going to go save columns. We want to save the predicted values. Save columns. Standard error of the predicted. And then we'll also be interested in standard error of the individual. And again, that's just the standard error for when we are calculating the confidence intervals for our prediction intervals. And save columns, our mean confidence interval, and our prediction interval. Once again, I can minimize, maximize our jump screen, and you can see that we have our saved columns. Our confidence intervals are standard errors and our predicted selling price. And again, if you need to, we can add rows and plug in the new information to try to generate new predicted selling price, standard error prediction, lower and upper confidence intervals. And so furthermore, we can say that in the same slide, say slide 49, that we can see our parameter estimates. That was on our original report. So was the overall ANOVA table. Talking about this exercise, slide 188, notice that you can take a single or both of the two simple linear regression reports and create the multilinear regression report. This is great practice and you should definitely do this. Now to talk about how to do a partial F-test. So under the fit model reports for our full and reduced models, we can pull our necessary sum of squares values from our ANOVA tables on these two reports and then complete the rest of it by hand, which is something that we do pretty well in the notes. Talking about our tire pressure prediction intervals, this is the same thing effectively as what we did in slide 172, but with a different data set. So just to give you an idea of how we can like say square something. So if we were caring about our tire pressure data set, so if I go back to eCampus and pull up our data, our tire pressure data set, it's still under other data sets. I'm going to open up tire pressure. So the data set itself has mileage and pressure. We talked about performing a transformation with this data set. So one thing we may first notice if we were to go to analyze, fit y by x, pressure is our factor, mileage is our response, and select OK, we see that we clearly have a quadratic fit. So, I mean, we do have the option of fit polynomial and quadratic, and it will kind of automatically then add in our pressured squared option. Or we could actually create the column ourselves on our data table. But one option, one thing that is going to be useful for us particularly in chapter 9 is creating this idea of all possible models. So if we consider our lung pressure data set, if we go to analyze, fit model, oops, I'm so sorry. I did not fully read. This is the second time I've done it. They want us to use our lung pressure data, not the tire pressure data. I saw the word pressure and just kept going. So if we want to be curious about a way to generate all possible models, sometimes it is a little bit handier to use a data set that has more predictors. So in this case, we're going to use the lung pressure data set that can still be found under eCampus, under our other data sets. So we have response Y and then our predictors X1, X2, and X3. So if we're interested in generating all possible models, we can go to Analyze, Fit Model. Y is our response, and then X1, X2, and X3, we're going to select Add. Now, in order to generate our all possible models, we can select, well, one way to do this, I guess, is we could be interested and do a full factorial. And so how that would look like, and I apologize, I've now digressed into something different. So I'm going to take a moment, get rid of all of our model effects. If we were interested in running our hierarchical model, so we want to see not only each individual factor, but also x1, x2, x1, x3, x2, x3, and x1, x2, x3. If we highlight all of our factors and select macro full factorial, this is stuff for chapter 9, and select run, that is one way to get our full factorial model. But that wasn't exactly what was written on the slide. I apologize, I did go off a little bit. So let me go back. If I go to our Analyze Fit Model Report, our response Y, X1, X2, and X3, add, run, minimize, so that I can see both the handout and our report. Under our response Y, we can have the option of selecting all possible models. But at this point, I'm having difficulty finding it. So let's take a second and see if we can't find it together. So it says on our resulting report, which we did, we should select all possible models under its red triangle. Okay, so if I don't see this, then before I select run report, I'm going to try this again. So I'm going to exit out of here. This time we're going to go to Analyze Fit Model once again. We know our response Y, and looking over, we can add. Now, I notice it says personalities. It says stepwise. All right, so there we go. This is where we went wrong. I did not select stepwise for our personality. Now, there we go. Red triangle, all possible models. Select OK. And we can get all possible models. And this is a very handy and useful thing to do, particularly if we're trying to find the best possible model with our predictors. And so we can examine our R squared, root mean squared error. The AIC and BIC isn't something we really look at in this class, but if you were to left click, we can right click, depending on which type of machine you're going to use. You can go to columns and you can get the Mallows CP option in order to find your best possible model. Personally, taking a look at this, I would say the best possible model is the model that includes X1 and X2 as the predictor, because it has the second highest R squared value, the lowest root mean squared error, and a pretty good Mallows CP. All right, so going back, last thing is talking about how we could make a residual plot. So at this point, I am going to exit out of the lung pressure data. And because this is something that we could use the real estate data for, I'm going to use that real estate data because it's one we've used so much and it is another saved column. So if I once again go to Analyze Fit Model, selling price is my response, size and condition are my model effects, it is least squares, so we're going to run. And this time I'm going to be interested in saving the residuals column. So if I go to Save Columns, Residuals, then we can minimize and we can use the graph builder in order to create a residual plot. So graph builder, residual selling price, and in comparison, We have our response, or I apologize. I just pulled size. And we're going to want a straight line to kind of give us an idea. And so as we can see, we can drag and drop. Remember, ideally, we want a cloud-like shape with no discernible direction. So I'm going to remove selling price. We can put size, change this to condition. And you can play around with this and make different graphs as you desire. All right, so that brings us to the end of our JMP video. If you have any questions on how to use the JMP, please send me an email and I can hopefully help you out. All right, everyone, have a good night.